Yo, what is up YouTube? In this video we're going to be discussing alternating series test. Above you can see the general format. It's -1 to the n plus or minus a times b sub n. It's that sum from n equals 0 to infinity. We got to be sure that we know as you take the limit of b sub n as n approaches infinity that it equals 0, and that secondarily b sub n needs to be decreasing. I made a bit of a mistake here. You need to have it to be greater than or equal to n plus 1. N is greater than or equal to n plus 1. So the terms are decreasing. In our first example, we're going to look at the sum from n equals 0 to infinity of -1 to the n over 7 plus 2n. So, how are we going to approach this? So first things first, we need to find what b sub n is. So b sub n is pretty much everything besides the -1 to the n plus or minus a term. Alright, so as we can see, b sub n is equal to 1 over 7 plus 2n. And we'll take a look at the limit as n goes to infinity of b sub n here. And we see that the numerator is going to get really large. 2 times infinity is infinity. 1 over infinity is really small number. We basically just call it 0, so that's going to be equal to 0. And then we need to check the second criteria. Is b sub n decreasing? And as it turns out, as the number n terms increases, we see a decrease in the value because the denominator gets bigger, so the overall value gets smaller. So formally we can say, therefore, by alternating series test, it converges. Let's go. Alright, now we're going to look at another series. This is also alternating series. It looks a little bit more tricky, but if we break it down to the fundamentals, it's not that bad. So right here I'm saying that the n plus 3 doesn't mean anything because either way it's still an alternating series. It's alternating from negative to positive, negative, positive. So we could apply this test. So what is b sub n in this case? I'd like you guys to pause the video and try and figure that out yourselves. Hopefully you're catching on. B sub n's the terms aside from the -1 to the n plus a power. So now let's take a look at the two criteria we need to say this converges. We'll look at the limit as n goes to infinity of b sub n. Well, if you plug in infinity for n, we see that the denominator gets huge and the numerator staying right at 1. Therefore, the limit goes to 0. Now for the second criteria, we need to say that b sub n is decreasing. Either otherwise said, b sub n is greater than or equal to b sub n plus 1. And that is true, and you guys can try and prove that for yourselves. So by alternating series test, it converges. Now that you guys are kind of getting the hang of it, let's try a trickier example. Now we're going to examine the sum from n equals 1 to infinity of 1 over -1 to the n times 2n plus 3 to the n, that whole quantity. Let's try and get this in a format that we can look at as alternating series, because off the bat it doesn't quite look like one because it's 1 over -1 to the n. But we could do a simple multiplication by a cleverly disguised 1, as my math teacher would like to call it. We're going to be multiplying by -1 to the n over -1 to the n. Alright, so we'll just multiply across with these fractions and we get -1 to the n in the numerator. In the denominator we have -1 to the 2n. Remember, when we multiply two numbers with exponents, we add their powers. And then same thing, we're just carrying across this to the n and the plus 3 to the n. And now let's take a closer look at this -1 to the 2n. Well, -1 squared is 1, and 1 to the n is 1 for all n. So we could just say the entire sum is the sum from n equals 1 to infinity of -1 to the n over 2 to the n plus 3 to the n. And I think from here you guys are getting the hang of it and you might be able to solve this on your own. So we'll be applying alternating series test. We see that b sub n equals 1 over 2 to the n plus 3 to the n. And if we take the limit as n goes to infinity of b sub n, we see it's 0, so that's good. And then we're also going to be looking at b sub n and b sub n plus 1. We see the denominators getting bigger so that the overall term gets smaller. Therefore, it converges by alternating series test. Now we'll be looking at the sum from n equals 1 to infinity of negative 1 to the n plus 6 times n over n squared plus 9. So this n to the 6 doesn't matter. We got to remember that it's still an alternating series, doesn't matter with that. So we identify our b sub n, and this time we'll have to do a little bit more tricky stuff with the limit with either L'Hopital's rule, or we could multiply by a cleverly disguised 1 to get our answer. And the math will be shown in just a second, and you can follow along. This fulfills the first criteria of the alternating series test, and now we'll look at the other criteria that it's decreasing, and it is. And if you want to prove that for yourself, you can. Alright, so I showed some cases where the series converges. In other cases, when some of these criteria don't work, we have to apply a little bit different logic, like absolute convergence, which we can talk about in a different video, as well as things like divergence test. And then if we see that the b sub n is not decreasing, then we'll have to resort to a different kind of convergence test. Thank you guys so much for watching this video. If you enjoyed, please smash that like button and subscribe to my channel for more content like this. If you guys are broke-ass college students like me, please go down in the description and get your free stocks from Webull.